Hello, this is a presentation of artificial telepathy, the interface human-mind-machine. Note that this presentation is about a study, a paper final presentation, and it involves theories only, nothing is practiced. Two note of these theories presented were placed in the test flat through based on fundamental theories. Here are presentation about a new technology based in nanotechnology and nanosensor for improvement of the scientific studies already done in neural science and computer versus human interaction. In direct words, they talk about the man-machine interface and the brain-computer interface. With this will be possible create a new technology that could be named commercially as artificial telepathy. Here are nothing based in fiction, but in real science, principally in nanotechnology and nanosensor. A nanosensor to artificial telepathy. How it can be implemented. In addition to the five natural senses we have believe that we will be finding have the power of telepathy. In the case, have the possibility to use an implanted nanosensor, invasive or non-invasive, as an improvement of human natural senses. It could be implanted in skin or only by a small sticker in the skin. And these chips include the nanosensor, a system to radio waves, emission, magnetism frequencies, and a connection wave frequency with the brain wave by spectral emission. We not by searches demonstrate in several papers that the medium wave frequencies in brain emission turn around delta 1 to 3 Hz, theta 4 to 8 Hz, alpha 9 to 14 Hz, and beta 15 to 30 Hz. Humans are full for this technology. Any of this is not only fiction, as already talked, but reality based in science. A real famous case is the physicist Stephen Hawking, where he used a human interaction system with computer to interact, or imagine a person without arms, lost in somewhere, etc., etc. In fact, this is a primitive way for a new idea for telepathy by nanosensors. The idea with brain-computer interface is a real and large possibility to brain-computer interface field of study by nanotechnology and nanosensor. And these nanosensors can be inserted in a glass to send information as like example the Google Glass, or send information to a cell phone non-invasive method. Or other case is sending the information directly to brain in a most sophisticated method, invasive method, with implanted nanosensors. In fact, there are thousands commercial and medicinal uses for this technology. And principally to bring in a practical way to our world all the information and the database of academics and theories studies already made by neuroscience, MRI, encephalogram, and other relevant studies about brain. The technology behind the artificial telepathy, the primary circuit involves the possibility of capturing extremely low frequencies waves, magnetism, or other waves, spectrum waves, used in high frequencies by the brain, and good interaction of the nanosensor by an architectural using hardware, software, nanosensor with the capacity of to transmission and reception of waves and interpretations as well. Tools like showed in the lesson of the course Nanotechnology and Nanosensor from Coursera, where Professor Hossan Haik demonstrated the forms where the nanoparticles can be functionalized. A nanosensor for detect waves is considered a physical nanosensor. A nanosensor to detect and transform in useful signal the environmental waves can be made by nanoparticles functionalized, preferable of polymers doped. For this procedure is necessary beyond the theoretical studies and the project laboratory experiments through characterization, material selection, and functionalization. Characterization, material, and functionalization. First of all, we need for this procedure is know the better and more sensitive material for detection of the spectrum of low waves frequencies inside the scope of the brain. Then, define the material with capacity of capture and emission of magnetic waves, so on. We note that magnetic waves are an energy to capture this. We need a material conductive, normally doped, a polymer as example, perhaps covered by a dielectric material if the nanosensor needs be implanted, an invasive case. So, if I get a polymeric material and doping it with electrical material, we are already have had a good material to work. But how capture the magnetic waves? The idea proposed is make small tables like a particle, where inside you have an emulsion fluid. This fluid semiconductor with nanoparticles, magnets. So inside this fluid have nanoparticles. The nanoparticles based in magnetic dots, like by nanotubes functionalized with magnetism sensitive. These nanotubes might be fabricated by CVD, chemical vapor deposition, as an example, in a case more easy, and functionalized by fluid synthesis. In each small table, particle functionalized with the nanoparticles inside could be made stickers to be allocated near the head user. This commercially allocated in a glass, in a sticker, in some souvenir for use non-invasive, or in other more sophisticated use by implanted way than in an invasive method. The project is definition of scopes separated by detector, nanosensor of the analyte, interpretation of the signal and electrical conversion, hardware for convert the signal in a machine language, software to make the algorithms processing, database for feeding the already acknowledged patterns, depth for interaction between brain-computer. The artificial intelligence and the use of pattern to communications. Here we note that initially we will use the capture and communication of only one letter of pattern of communication. The most sophisticated communication system will be improved with the time. At the moment, we propose is calibrate this method at the moment in theory and know the magnetism means communication system. Conclusion. As demonstrated, it is a fiction, but a real application method based in scientific research already made. The benefits for millions of people are clear too in medicine case, without considering the immense potential of commercial use full as well. Thanks for watching.